Alright, so area is just the integral from -2 to 2 of f minus g, so of 4 minus x squared minus 0, right? So let me worry about the 0 right there. So that's going to be 4x minus x cubed over 3 from -2 to 2. Is that correct? Agree with that? Alright, so that's going to be 8 minus 8/3 minus -8 plus 8/3. Agree with that? Make sure my math's right. 2 times 4 is 8. 2 cubed is 8, so that's right. 4 times -2 is -8. -2 cubed is -8. So minus a negative positive. So I'm going to distribute that, and that's going to give me 8 minus 8/3 plus 8 minus 8/3. That's going to be 16 plus 16/3. Is that correct or no? Am I correct? 16 minus 16/3.
You get 32/3.
Okay, so really 48 minus, yeah, 60, 30, yeah, 32/3. Very good. Okay with that? Makes sense? Okay, now volume. With squares we built on top. We go from -2 to 2 of that same equation squared. That's going to be 16x minus 8x cubed over 3 plus x to the 5th over 5. Let's use a calculator for this because I don't want to waste time doing that math. That's going to be all kinds of horrible fractions. Is my math correct so far? Have you agreed to anything done?
Volume, do we have to put, like,
It will ask you for units if units are required.
Okay.
It will specifically say use indicated units, and that will be a point. So if you see anything about units, you want to make sure you get the units down. So it should have been 34.133.
Yes.
All right. So now for the part I want to focus on today. Everything we've done till now is review. All right. These 2 steps review. Step C. We're going to take both equations and solve for x. So y equals to 4 minus x squared becomes y minus 4 equals to negative x squared becomes 4 minus y equals to positive x squared becomes x equals to plus or minus the square root of 4 minus y. And do I want both of them? I think I want both of them. I definitely want both of them.
Because the y was 0 is right.
Yeah, well, what I was thinking about was it going to be just in this quadrant? But it's not, is it? What y'all did a while ago was from -2 to 2, right? So we're going to do the same thing then. We're going to instead of building stuff this way, we're gonna be building stuff this way. Okay? So, we've got our x equals now. So f is going to be which equation? The positive one, and g is going to be the negative one. So if you
Same
wanna-
balance?
No. No, if you look at your notes I gave you right here, there's two things you gotta do. You have to solve for x, and you have to change the balance. The balance becomes vertical balance, bottom to top. You okay with that? Everything else we've done was, up till now, has been horizontal balance, left to right. Now we're going bottom to top, because we're going on the y-axis. So what I need to know is, what is that point? And what is that point? Well, that one's easy. That's 0, 0, right? That's 0, a y of 0. What is this one?
I'm betting it's
I'm betting it's 4. Okay? I'm betting if you don't know if it's 4, you can plug a 0 into your equation and that original equation right there and say 4 minus 0 would still be 4. But, you know, starting point, right? So our integral is going to be from 0 to 4. F, well, what was F? I'll write this way so you can see it. So 0 to 4, F, what is F? 4 minus y, the positive 1, minus, what was G?
negative 4.
Negative square root of 4 minus y. Well, that's the equivalent, and get this, this is worth a point. You must have a dy on either side. And because we're building rectangles, this should all be what? Squared. Squared. Just like this one was squared up here. This one should also be squared. Well, that's going to simplify down to 0 to 4 of 2 times the square root of 4 minus y. And that's going to simplify down to what? Before I integrate, down to what?
4 minus, or 4 times 4 minus y.
4 times 4 minus y. And like I said, you can distribute this point if you want to. It may be easier, I don't know. This is just always my default. I always go back to this. So you integrate that and you get 4 times 4y minus y squared over 2 from 0 to 4. Make sure you agree, make sure I did it right. You guys all good with that? That makes sense to you? So that's going to be 4 times 16 minus 8 minus 0. So 4 times 16 minus 8, that's going to be 8 and 32, is that correct? So let me bring up, just so you guys can visualize what happened here. I want to make sure you're understanding. Okay, the first equation was 4 minus x squared and 0. So 4 minus x squared and 0 from negative 2 to 2.
Never mind,
Do I have it correct or no?
yeah. I thought you already went to the y-axis one.
I'm going to. This is the x one. I want,
Yeah.
This is what we just did. That was this part B.
Easy buckets.
Easy buckets, right? Everybody makes sense to you? You good with that? All right, so here's perpendicular to y. So perpendicular to y, I have x equal to, what was our equation? Square root of 4 minus y. 4 minus y to the 1/2 power. And negative 4 minus y to the 1/2 power. And instead of going from 0 to 2, we're going from 0 to 4 along the y-axis. And now you can see it building up this shape. It's working. And so the question is, A, are the volumes the same, and B, are the shapes the same? You look at the answer in B and C and realize the volumes are not the same, right? It was 34.1 versus 32. The volumes weren't the same. And the shape is also different because this is some sort of, I'm having a hard time picturing that, but definitely a different looking shape, right? Okay, be good? Make sense? All right, let's try the next one.
It's a nifty website. That's some nerd with too much time on his hands.
It was a nerd with way too much time on his hands. You're exactly right. Or it was somebody who really cares about his students and was trying to help them out and realized the topic is difficult.
Could be that.
That's a possibility. There's probably a nerd with too much time on his hands. Probably.
Nothing better to do.
That's a better.
Should publish that tool for like other teachers to use. Sell it.
Make some money.
Make some money. What'd you say, Alex?
I'm making fun of the Herb Jones guy.
Herb Jones.
He said,
That's my brother.
he was like, yo, he was showing us like, they sell like shirts that say like class of 2019, like jewelry, you can get like jewelry that says, and he was like, now you can have that senior drip.
Really?
Well, he said,
And I was like-
senior swag, and then he was like, that's not cool, never mind what he all said. He was like, oh yeah, senior drip.
He was like, I've never
Get that
said-
senior clout.
Must have been bigger shoes.
So they already come and sold you all your class rings and stuff like that? Last year. Okay.
Number 2 is both perpendicular to x-axis.
Find the volume perpendicular to x. Are they both perpendicular to x?
Yes, sir.
Oh, that's sad.
You want to skip it?
No, we're going to do both. We're going to do x and y. But that's what we're doing.
Wait, if it doesn't give you another y equation.
It's going to be tough to sign of x. So let's think about that. It'd be arc sine.
Shoot.
Let's do the do A first. Get that part done first, and then we'll see if we can do B. I have to think about that for 1 second.
Find out what we're using. What? What are you going on about noise? Says you
They already gave you bound modes. Yeah.
Oh, I was using those as the.
The floating rangers.
Drip.
Don't even understand that. That means
I don't know.
I'm kind of terrified. Yeah, we can do arc sine. That'll work out for us.
What?
Go ahead. Keep doing part A.
we gotta integrate that bad boy.
But how?
Yeah, what's
Sine of x squared integrated?
sine?
Sine squared. Yeah.
We don't know that. It's not one I have memorized.
Let's just use our calculator. Okay.
Who's Jones with brilliant ideas?
You're right, you don't know how to integrate sine squared, but you can use your calculator.
Do not.
But these
One
bars that we
1.5.
spit out now are so fire.
What do you get, Hannah?
1.570.
Did you multiply by square root of 3 over 4?
What?
Equilateral triangle?
Oh, my bad.
The mighty Hannah has fallen.
Somebody Hannah struck out.
We have 0.680.
I got .332.
Yeah, that's not right. I got it wrong. I got 0.680.
I got
Uh-oh.
0.680.
Uh-oh.
I got .680.
Anybody not have .680 at this point?
I'm working on it.
0.680? Alex gets snapped up from a girl coach.
Oh yeah?
Oh, yeah?
I got .682.
Okay. So, that's perpendicular to x. Now if we're going to do perpendicular to y, step 1, I'm going to call this part A.2 here, okay? Step 1, we're going to solve the equation. We'll solve this equation first, and we'll figure out what we're going to do the next one. Y equals sine of x, we're going to call that, anybody?
Sine negative.
Sine -1 of x, but, well, of both sides.
Y.
Yeah. So arc sine of both sides. We will undo the sign on the right, giving you x equals to arc sine of y.
Big.
Okay? Now we need to figure out where our other one's going to be at. So I have a couple different options here. The graph looks like this. So we could either do just from here to here.
Are you solving for y even if,
This is the original equation they gave us.
Or, no, that's not
What was
right.
that?
Are you,
Few push-ups.
10.
Give me push-ups until I get done talking to her.
what did he say?
You don't
no,
know.
I'm down for that.
So find it eventually.
Perpendicular to the y-axis, are you just doing that even if
Yes.
it's not asking?
Doesn't ask for it. We're doing it
Okay,
anyway to
that
practice.
makes sense.
Okay, I'm done
Should I
talking
hear
to her.
my
That's what I'm
question?
looking for.
Should hear my question. So, what's our balance?
So that's what I was just talking about.
Oh, okay.
Because this is arc sine, and it's not real specific, we're kind of making it up here. We can either go from 0 to this point, or we could catch, because arc sine technically goes from there to there, we can catch both sides of it. Why don't we go ahead and do from 0 to this point first, just keep the math simple, okay? We'll just do this piece right here.
Those would be the same, it would just be the negative, they'd be the same points, one would just be negative, one would be positive, right?
I'm asking you, what's my balance going to be? Zero to pi.
0 to
or-
1.
0 to 1. Tell me why it's 0 to 1.
Because.
Arc sine of.
Sine. No.
something.
Sine of pi is 1.
Sine of pi is 1. That's our highest point right there, right? The highest point we ever got was y equal to 1. Now, if we were building it on both sides, we'd go from -1 to 1. We're just going to build it from the middle. We're just going to do just this part right here. Okay? So we're going to integrate from 0 to 1. Sine -1 of y. Because I'm building a what shape?
Triangles.
Triangle.
Square root through.
Square root of 3 over 4. And what am I doing with arc sine of y? Squaring that. And I doubt that we have a formula for that one either, so you're going to have to use your calculator. If you're not following what we're doing here, holler at me, because you need to get this through your head.
So how do you make it like x equal y in calculator?
Probably, it doesn't matter. So in your calculator, you can type in x and dx.
Okay.
As long as your bounds are correct, your equation's right. You
You just
can,
make it sine -1 over x.
yes.
Okay. Been confused.
And make sure I'm not lying to you too, but it should be correct.
Got a big old fat bacon. 0.202.
That's what I got.
We must reach.
Well, duh, portion sheeting.
See, that's a big fat cheat.
.202. If I do the same thing with dy and y, alpha y.
Calm down in there. Must be cheating.
Okay, eyes up here. So I did it per 3 over 4 times arc sine of x squared dx. I got 0.2. And right here, arc sine of y dy. Use the same answer.
Same.
How'd you do it?
Ma'am?
How'd you do that?
How to get the y's in here? Alpha, the green alpha button, and 1, number 1. That's your alpha y right there. My point is you can type in your calculator x's or y, it doesn't matter. But if you don't have this written on your paper, you lost points,
Points lost.
okay? Even if you get the right answer, if you don't have this written down correctly, you've lost points. All right, do part B.
Do you want us to do the
B,
Time.
x, and then part B across the y, okay?
Some of my circles, we're gonna have it. Over 8 times it. So let's just, yeah, let's do it. Original bounds. I guess we can use our calculator, right?
Yeah.
What's it?
Okay.
I got the exact same
Mhm.
answer. Definitely cheated. You know what I got? What'd you get, Alex?
0.426.
That's not good.
I don't know what you got.
You do semicircle?
You squared the equation when you first
Oh,
did it.
yeah. That's what.
Silly, really. Point six.
Do you not have to divide by 2? I got 0.785.
She may be onto something, I don't know.
Oh, I forgot to explain.
Oh, that is not cheap.
Should be .616.
Thank you, Coach Jones.
Just forgot to.
That's
So I'm gonna round it like to 0.617.
Okay, so you can round or not round.
Okay.
I typically recommend you just truncate that way. It's less things you have to worry about, think about. What you see in your calculator, right in the first 3 digits, you're done.
Okay.
Just trying to make your life quick and easy on the test. You'll have plenty of things to think about. All right, let's go ahead and do B part 2, perpendicular to the y-axis.
Hold on. 0.183.
Man, why don't you slow down a little bit? Wait, you said 0.183? That's what I said as well. Should go up so fast. I like those little blue spiral coil. Coil?
If y'all are done with that one, feel free to start on number 3. That way you talk less and work more.
answer. I got it.
Let me see.
That was my stomach.
So, if you did not have a calculator, where would these things cross at? What would be the bounds? I haven't done it yet. It may not be possible to do that calculator, but I'm asking if you didn't have a calculator, what would you do to find the
Set them
bounds?
equal to each other.
Okay.
Then you get x equals negative y to x cubed.
So, this is when you're going to have to have a calculator because you want it with x's on both sides, right? Point would be that you would need to get x's on one side only. I don't think it'd be possible to do that in this one. So use your calculator and figure out where these things cross at.
You get a quick calculator.
I had x equals 1.857.
So you'll want more decimal spots than that.
1839.
Okay, you'll want about 5 decimal spots. You just want to make sure you don't have any rounding errors.
Mine's still graphics.
And mine's up here.
So you gotta get 2 spots?
No, because if you read the directions, it wants it from, well, it does want the area, doesn't it? So, would you get 2 spots? Let me see here.
Oh, you know, there are.
Are we
2
going from
spots.
0 to?
Oh, it says the y-axis right here. So this is your bounds, which means we're talking about this area right here on the right side. The y-axis is a bound
So from 0 to,
from 0 to that number you had.
which was 1.857.
Make sense to you?
39.
So what I would typically recommend you do is, because you don't want to write that number down every time, I would come over here and say let AB equal to those coordinates. And I'll show you why here in a second. Point AB, right? So what was the x part of that? We're going to need both of them, aren't we?
1.857.
1.857 what?
857 1839.
18. Okay, we'll call that good. And then the y coordinate?
6.405672.
6.40572. Close enough right there. Okay?
Tracy?
Yeah, that's what
I'm gonna be Tracy.
This is a speed thing, right? I'm trying to help you out. By doing this one step, for every problem I'm integrating from 0 to A,
Oh, we
or
don't
from
have to
0
go
to
back.
B. I've written this down, it's on my test, I only have to do it one time. It's a lot of writing, I have to do it every time, okay? Especially if I'm going from B to A. It's a whole lot of decimals to have to write down.
So we have to write let A of B.
You do have to write it down somewhere on the paper, yes.
And
And then from there you can use it, okay? So if we're talking about the area, then I'm going, hush. I'm going from 0 to what?
A.
0 to A. Then I'm talking about the X, right? I'm going this direction. From 0 to A. Which one is above the other one?
X cubed is above. I think.
No. X cubed is
Nope. Crap. You were right, Alex. EDX minus.
dx minus x cubed dx. Choose your calculator.
Better type that big number in the calculator.
Would that not be squared?
unless you store
We're through an area, right?
3a is just area.
Oh.
Right, the area of our
Johnny, okay? Alright, tell me what you'll get as an answer. Oh, yeah. Alex, you get an answer?
what'd you get?
2.431.
2.431.
Yes.
Do y'all agree?
Mm-hmm.
Yes, Elena? Let's make sure.
2
Okay.
Alex, every time you breathe, you just
All right. Now do part B.
I assume you use your calculator.
Yeah.
Yeah. It says. Oh, I'm on 3. I'm
Triangles.
on 2.
You can still use your calculator. I don't want to waste time on the actual math. Just use your
I'm
calculator.
just saying I didn't. Hey, what are we right here then? I was looking at number 2. And also so.
It's not okay.
How do we do this? Math knowledge.
Square root of 3 over 4 times 3s.
Did it say it was equilateral triangle?
You say equilateral, 3 times
Square
length of the
root of
base.
So you just
Square root of 4 is
multiply
equilateral triangle.
3s
It's just 3s squared.
divided by 2.
She's asking you a question. You can answer.
I'm thinking.
Wow, Alex. Come on.
Yes.
Wait, so what?
So just 3
You
over
have 3
2
over 2.
on the outside of this bad boy.
Okay.
Is that right?
It says the cross sections are triangles. A triangle is 1/2 base times height.
The base is
The base is this.
So height is another 3 times b squared.
So the base is right here, e to the x minus x cubed, and the height is 3 times that. So that is 3/2 0 to a e to the x minus x cubed squared dx. Don't forget your dx's. It's probably always a good idea to start right here too. There's no points in this, but if you start by writing down the original area equation, you're less likely to make a mistake. You're not going to assume square root of 3 over 4, for instance. She's ignoring me back there.
Sorry, I was focused. What?
5.267.
That's what I thought.
Or 5.267, you said? Yep. All right, part C is going to suck a little bit. I'm going to redraw this picture so you can understand why it sucks a little bit. We had this shape and we had this shape. Is that correct? Okay. The cross section, find the volume solid on region R. Here is region R. The y-axis. We're about to start doing this right here. And what I'm trying to figure out is
How to keep it from getting to the other side.
yeah, so here's our intersection point right here. So we can't, this is why it's going to suck. We're good to right here, because this is the correct shape. But once we get to right here, because of this y-axis, this is no longer valid, because that's not the y-axis, is it?
Ooh.
This is the y-axis. It's going to be two equations.
Cal Mutt, come to the office, please. Cal Mutt.
That's insane.
It's going to be from 0 to this point right here. I'm going to call this point C. And then from C, that was our point B we had a while ago. It'll be integral from 0 to C plus integral from C to B.
Why can't you just solve for x and move the equation?
You're going to. You're going to.
Okay.
But this shape hasn't changed. And the requirement was it had to be bounded by the y-axis. This from here to here is not bounded by the y-axis.
But wouldn't, it's not bounded by the equation either, so would it even be part of it? The B to C?
See, all this right here is not bound by the y-axis, so it
Yeah.
would cease to count.
So when you
This is bounded by the
disregard it
y-axis, and this equation from here to here, this is the y-axis and that equation from there to there.
Oh, it's x equals 0,
Yeah, but
that
it-
one, and then x equals...
Yeah, but if you know, since you're doing just the left y-axis.
So at the bottom of your page, the math is set up here for you, so you can check your answers, okay? At the bottom of that online page, so you can check your answer. I'm telling you what they're doing. They're breaking it to pieces, so from 0 to C, and from C to B.
Why do you stop at B? Why don't you just go all the way up?
Because it's the bounds, bounded by these three equations. Those three equations, these two intersect right there, so that's going to be the end of it.
But why is this not on the y-axis?
Because if we're saying this equation minus this equation, we're just bounded right here. We'll talk about it in class anymore, but I just want to show you this. When you look at their math, this is what they're doing. They're ignoring this part right there.
Okay.
Do you want our test corrections?
I do! Test corrections. How about John? I want test corrections.
John, class corrections because all of mine I got results. He left mine as well.
It's in that locker, please. Put them on the bottom
President
shelf.
Williams, come back to the office.
Bottom shelf?
Bottom shelf.
Test back as well.
Sir?
Test back as well.
Test back as well. I don't know if it's a stapler or not. Just stick them down there. You're fine. Fold the corner over something.
Mark my name on my test corrections. Cameron.
I'll kick John.
I'm Brandon.
See you, buddy.
Bye.
See you, buddy.